Hello, and welcome to the 2020 Farm Progress Virtual Experience Irrigation Breakout Session. I'm Brian Magnuson, Vice President of the Americas with Lindsay Corporation, and we're the proud sponsor of this educational session on deficit irrigation. At Lindsay, we're committed to creating a more sustainable future by equipping growers with the information, insights, and solutions to run their irrigation systems with precision while conserving resources. Since 1955, Lindsay has been a pioneer provider of irrigation and water management solutions. From the strength and durability that Zematic irrigation systems are known for, to the intelligence and advanced technology features of FieldNet, our portfolio of industry-leading products and services help conserve resources, increase yields, and benefit growers worldwide. With customer-first innovation really at our core, we are driven to advance the irrigation industry to deliver meaningful water and energy savings while helping our growers to be the most profitable they can be. Our company has a goal to help growers save more than 700 billion gallons of water and more than 1 billion kilowatt hours of energy by the year 2022. Every year, we look forward to meeting growers like you at trade shows to discuss solutions that you want, to address the needs that you have in your operation, and to help you be sustainable and profitable over the long term for your operation. While we can't meet face-to-face this year, we're excited to sponsor this session and help bring you quality information and solutions to help you make every drop count. Thank you for joining Lindsay at this irrigation breakout session, and we look forward to seeing you in person at Farm Progress and Husker Harvest Days next year in 2021.
Hi, and thanks for tuning into the Farm Progress Virtual Experience Deficit Irrigation Breakout Session. I'm Tyler Harris, and joining us today are Ferris Hightower, Regional Sales Manager at Lindsay Corporation, Joel Schneekloth, Extension Regional Water Resources Specialist at Colorado State University, and Darren Rudnick, Extension Irrigation Management Specialist at the University of Nebraska-Lincoln. Starting us off today will be Ferris. So Ferris, do you want to get us started?
Okay, so we'll talk a little bit about deficit irrigation here today, and ultimately what we're trying to do is utilize an irrigation strategy that will allow us to maximize our returns while reducing the amount of irrigation water that we utilize. Your crops are definitely going to sustain some kind of water deficit, which will affect yield in most cases, unless we get rainfall that is timely and helps us to meet the need of the crop when we need to. We're going to apply the water only when the crop needs it the most, and we're going to utilize the soil storage capacity to help fill in the blanks that we have in between our irrigation or rainfall events. And we're going to do everything we can to maximize our rainfall events during the season and reduce as much of the evaporative losses during the season. So if you go to the next slide. So we're going to delay that first irrigation early in the season. And a lot of that is going to be around developing the root system underneath the crop. We'll work to get the crop established and then delay that irrigation as long as we can while it roots down, and then apply the water at the point that it'll do us the most good. We're always going to try to put as much water on as we can with every irrigation event, trying to prevent runoff, but utilizing storage in the soil. So every time we go around, we're going to, with irrigation, or anytime we apply irrigation, you're going to have a certain amount of loss. So we want to reduce the number of times that we allow that loss to happen. We're always going to allow some storage in the soil for rainfall events, so that when we get one of those, that we'll be able to store the water. And then we're going to really work hard at timing that last irrigation of the season, because one of the things we see a lot is people overwater at the end of the season, and by using crop models and irrigation timing, things to time that irrigation, we can certainly save an inch and sometimes 2 inches at the end of the season. Go ahead and go to the next one. So when we look at trying to reduce evaporative losses, I think the key thing, the way we look at it out in the field a lot, is closer together, closer to the ground is going to result in higher application efficiencies. In other words, we should be able to get more water to the ground if we use bubble pads, if we use low space drops and we put that water right down on the ground and keep it off of the plant surfaces, leaf surfaces, and try to get it into the ground and maybe underneath some of the organic matter and stuff that might be on top of the ground. And by low and slow applications, we'll get the most out of that water that way. We'll get all of our uniformity as much as we can by closing the drop spacing down. Sometimes training going to allow us to do that, but where we have the opportunity to do it, close it down as much as we can, but and use as big a droplets if we have to put it into the air, so that we get as much as we can to the ground. So let's go ahead and go to the next slide. So it's really important that we have full control of the systems, because that way you can start them and stop them as you want. You're not tied to, well, when can you get there? That you can put that using remote control technology, really be able to get control of that irrigation instead of it having control of you. And that'll also allow us to maximize the amount of uptime that we have and minimize the amount of downtime, because irrigation equipment never breaks down right before you get there. It's always right after you left. And so it allows us to have the most uptime. That's really critical in our deficit irrigation areas. And then by having full control, we can monitor and record all of our as-applied irrigation data. That allows us to drop that into our irrigation scheduling programs, use the crop models, and based on actual field conditions, decide when and how much irrigation water to apply. And all of the current technologies in monitoring control allow you out of the box to be able to apply variable rate irrigation strategies, so that you can vary stuff as you go around the field. If you got an area that's in a low spot and doesn't need the water as much, well, you can cruise through there. If you got a rocky cropping somewhere or something like that, get across it. That water's not really going to help you as much. So it allows you to have some flexibility in that water application. Go ahead and go to the next slide. So timing's everything. Being able to use something like, and I'll talk about FieldNet Advisor, because it is really a nice out of the box way to model a crop, because you've got all your as-applied irrigation data. You can look at upcoming rainfall events and their probability. It helps you to track not only the rainfall on the circle, one side to the other side, allows you to really base the amount of water that you want to apply on how well developed that root system is, and where you're at with your crop development. And it'll take into account the soil type, your organic matter, the amount of residue that you have, and the efficiency of that water application. And when I say efficiency of water application, I'm talking about just the part where it allows you to get the water from the nozzle to the ground. There are other factors in there that if you run short on water and therefore are short on pressure, that's going to show up. That's a whole different thing. But it does allow you to monitor all that stuff and make decisions and keep your equipment maintained the way that it needs to be maintained. And we want to automate the process. And one of the things, as we kind of have a go forward in this industry, we have to have products that are scalable. We got to be able to put it across many acres as quickly as possible with the least amount of labor involved, so that you can get it on, get it taken care of, and then start utilizing it to make decisions in irrigation. So let's go ahead and go to the next slide. So just a little bit on one of the guys that we work with a little bit is a fellow down in the Texas Panhandle, and Brian grows some corn, wheat, alfalfa, and then he grows some specialty crops. And what he's found during utilizing irrigation scheduling, close spacing drops, really tweaking that thing out as best as he can. And he runs about a 7 to 7.5 day circle time. And he's working with in that 3 to 3.5 gallons per minute range. But by delaying irrigations early in the year and then working hard during the year to go, and then really watching that crop development and where you land at in it, that he can save an inch at the end of the year, sometimes 2 inches. So pretty easy from the things that I've seen to be able to save 2 inches of water across most irrigated acres by scheduling irrigation and paying attention to the crop development, that kind of stuff. And that generally is going to result in about a 10% water savings. The value of that water long term is really the value of the resource, but there is a significant economic impact depending upon the depth of pumping. So I think that's kind of where I land on the whole deficit irrigation strategies. I mean, we can maximize our resource, and we can help with economic benefit in there, but there's a lot of work that has to be done. So that's all I got.
Thank you, Ferris. Next, we have Joel Schneekloth.
I have to unmute myself. Going to talk about irrigation management and the residue management a little bit. I've been doing this type of work for 30 years now on limited irrigation water management for this. And we've been really focusing on the residue because there's been a lot of misnomers out lately about how much water you can save with residue and where the residue's at. And lately we've been having a lot of talks with producers and industry on the value of that residue. We have supposedly a cellulosic ethanol interest somewhere in the state, and they keep saying, well, farmers want to get rid of the residue. And we have to show them, producers, no, it's worth a lot more than you think. So go to the next slide. So one of the things I want to talk about is, leaving as much residue as you can on the soil surface. We have people that are strip tilling, but they get relatively aggressive on their strip till. That bottom right corner, you can see that this is a very aggressive strip till. We don't have much residue left in between the rows is basically where you see it. Evaporative losses will not be really reduced by this kind of a strip till management. We're warming up that soil in those strips, and the water from between the strips is really moving into that drier zone. So you want to do as much minimize that disturbance as much as possible. You see that upper right, that's about as much disturbance as I like to see on a strip till machine. That's what we're doing here. We've gone to that versus no-till because of our pH levels. We run right about 8% pH. We're sitting at 4,600 feet in elevation here. So we have cool springs and a lot of iron chlorosis, so we're trying to find ways to minimize that. Next slide. One of the things, hit the button again, because I only see my picture. There we go. Average annual gains, we see on average about 1.5 inches. And here we're talking about soil moisture capture, precipitation capture over the winter with residue. So 2017 was kind of an average year of snowfall along with 18. We're seeing anywhere, upper 50s to mid 30, upper 50s, low 50s% capture of snow and into the soil where we leave the residue standing, where we've either tilled the residue in or harvested the residue as a cellulosic ethanol. Those 2 years we were seeing, mid 30s. But we get a year like we did 2 years ago where we had very little snow relative. We get about 30 plus inches of snow a year on average. 2019 was a lot of small events, not really effective typically. But again, we're seeing with the residue standing in the field, we were gaining, the low 50%. But where we took off the residue, we were in the mid-teen% recovery on storage. So it's important. Gather all that moisture you can that Mother Nature gives you and store it. It's free water. Don't get rid of it. So that's kind of the point there. So that's already 1.5 inches more in moisture that you start out with when you leave that residue in the spring, till spring at least, rather than doing any tillage in the fall. And I know people are always talking about, well, I have to do tillage in the fall because of time zone. or it's my soil type. Well, this is one consideration you have to look at. What's an 1.5 to 2 inches of water cost you to pump? Or if the water's short, what's that 1.5 beginning of season worth? Next slide. So here's, plant available water. We're doing a study on that residue management with limited irrigation. We're doing about 30% less than what we typically apply in a normal season. We normally are about 13 inches, and we're maximizing out at 10 here on this study. But we can see where we start out in 16, we're starting out with 10 inches available. A full profile for us would be closer to 12 inches at the beginning of the season. And you can see that where we took the residue off, we're a little bit less than that. But you can see the continual decline in available moisture through the growing seasons, 16, 17, and 18, where at one point where we take the residue off, we're starting out less than 50% available in a 6-foot profile already. That's moisture that you're going to have to recuperate either through precipitation and good precipitation or irrigation water. So we're starting out that, and I'm typical, the cumulative effect, even with deficit irrigation, leaving that residue there, keeping it on the soil surface through the growing season, is we're at the end of 18, we're starting out with about 2.5 inches more water at the beginning of the season as compared to either fall tillage or harvesting that residue. Go ahead with the next. No-till reduces evaporation, ET, through the growing season by about 3/4 of an inch through VT, vegetative tassel. Now, why people have always said, well, it's higher than that. It's higher than that. Well, when you're growing a crop that actually develops a canopy, that potential gets reduced. So what we're seeing is those type of systems where on average is about 3/4 to an inch by the time we hit vegetative tassel or beginning reproductive. Some years it's been as high as 1.5 to 2 inches, what we see like in 2017. That was a year with little precipitation. We were doing some irrigation early, but that evaporative losses, change in soil moisture, was about 1.5 inches by the time we hit reproductive. We had 1.5 inches more stored soil moisture. So what we're seeing there is either we can reduce our irrigation during that vegetative growth stage with no-till, or we have 1.5 inches more moisture to get us through into reproductive. And that's the critical time period where you really want the water, reproductive growth stages. That's where you get the most bang for your buck for irrigation on corn. So go to the next. And this is this year's data, and this year's we've been drought. Since June 1, we've had less than 3 inches of precipitation total through June, July, and August. High evaporative losses. We've been pushing 90 degrees for the second highest number of days through the year. We actually finally got a cold front, and this morning it felt chilly, and we were down around 60 degrees. Thought about getting a coat out. But we see the gradual change through the growing season, beginning growing season. So we're starting out June 8th. We see a look to June 22nd. What we're looking here is the difference between no-till with residue, tilled with residue. So the till, we have about a 50% cover with the tilled with residue and a full cover with the no-till in this situation. So we start out June 8th. We see to June 22nd, we see a little bit of an increase in soil moisture. That June 22nd to July 6th is where we really saw the big increase. Well, there we had a lot of wind, close to 100-degree temperatures, very dry, what we call advective conditions. So it's a lot of mixing into the canopy of that dry air, causing a lot of evaporative losses in that system. So we saw that big increase there. And then the next week, we still see an increase. We still see an increase. And once we hit that July 27th to August 3rd time period, that's where we hit vegetative tassel. We're starting to utilize that moisture that we stored by having that residue on the soil surface at that point in time. So this year, it was 1.1 inches in the top 3 feet of soil. So that's one less irrigation, or that's that much less water we have to pump to equal the tilled with residue. So the next. This is looking at stored soil moisture at that August 3rd time period. And you can see right there, and we started out the season very similar, but we can see that 1.5 inch difference at that point in time down the second and third, even slightly into the 4th foot. Not much in the 4th foot. But that's water that we have available where that green line is that no-till with the residue available for the reproductive. And we can see how much water we pulled, and that's volumetric change. So each percent volumetric in our soil is about a little over 1/10 of an inch. So you look at the difference. We are 9% volumetric pull versus 7, so that's 2/10, another 2/10, and another 2/10 at this point in time. So that's a lot of water we can utilize later and hopefully shut off irrigation earlier. Go to the next. This is grain yields, and the ultimate is, how do these systems pay? We've always seen producers, well, I can't do that for that because of economics. I don't get the big yields. Well, this is with 10 inches of water maximum, and I'll give you a little caveat here later, but 2015 was a wet year for us. Look at that, those yields, we're pushing up close to 250 at that point in time, and then we're sitting at 190 to 200 bushel range, a lot of for the next 3 years. 2019 was probably one of the worst growing conditions for the opposite. Very wet, very cold throughout the growing season. The corn just stayed chlorotic, even in the tilled that whole year. And everybody in this region was seeing 25% less yields as compared to usual. But the no-till stayed right up there with the residue. We see that on average, that five-year average, tilled with residue was about 3 bushel more than no-till with residue, with 10 inches of irrigation maximum. And here's the caveat: the no-till with residue was 1 inch less irrigation every year. So we saved 10% water, came up within 3 bushel. So you can look at it either two ways. I saved 10% of my water, or I could have irrigated 10% more acres with residue management. So that's the caveat you got to look at, plus the savings of tillage, other things throughout that system. But one of the key things here is, as we do the residue, take residue, like in 18 and 19, we started seeing increased reductions in yield as compared to where we left the residue over the winter, because of that soil moisture deficit that we were seeing gaining throughout this time period. So next slide. Here's some caveats here that we'd look at. Is eliminate that fall tillage. Don't even bother. Leave that residue standing. I keep telling people that is worth gold. But when we're looking at different types of deficit irrigation or limited irrigation, we got to look at quantity, which is an allocation, versus capacity. Now, Ferris is talking about capacities a lot down there. That's a different management than allocations. We're in regions here that just east of us, they're about 11.5 inches per year that they can pump. We have the Limas in northwest Kansas that are talking 9 inches of pumping available, but they have capacities in most of those regions. So it's differences of how you manage that. So with an allocation, you try to minimize that irrigation during the vegetative growth period. Sometimes you have to turn your eye because you want to irrigate, the crop looks tough. Turn the other way, depending upon the time period it is and the reproductive or vegetative growth stage it is. Try to line all the irrigation capacity to peak water needs as much as you can. There's been studies showing that 70% of the yield variability is shown by how much water you receive during that vegetative or reproductive growth period. So that's why we try to really time that water as much as possible. One I didn't put in here with a lot of it is choose the right varieties. One year we were talking about it, and the guy says, well, I have this variety. Well, it was a racehorse variety. And they had a yield trial near them. It was the top yielding irrigated variety, bottom yielding dryland variety. You don't want those. They cannot handle stress. If it's a capacity, a lot here, if we don't have allocations, they're irrigating early, try to maintain and build that soil moisture. That's where that residue management comes into play and hitting it. But they always try to build moisture for that reproductive time period, and it doesn't always work 9 times out of 10. So we take a look at that and say, base your irrigated acres on a capacity that's needed for that reproductive time period to meet the water needs, splitting the pivots between the crops so they don't overlap. Irrigated corn, irrigated winter wheat, or a dryland winter wheat, depending upon how much water you have. This isn't about hitting high yields every year. It's about consistency and minimizing variability within the system. I don't want to hit 270, 280 one year and then have 150 the next. I'll take my 220s, 230 bushel corn year in, year out, because of that variability. Typically goes when you hit the 170 is when you hit the high prices. When you hit the 270s is when you hit the low prices. So you try to look at that consistency and for cash flowing as well. It's not about hitting the home run every time. I'll take a double or a single or a double every day versus a home run once every 3 to 5 years. That's kind of 30 years of experience with this. And I know from Ferris, he was talking about, the runoff issues and that. We have terrain, so we try to keep our sprinkler packages a little higher. But we always say, maximize that droplet size. Wind movement and evaporative losses are minimized. I think that's it for me.
Well, thanks a bunch, Joel. And next up, we have Darren Rudnick.
Excellent job, Joel and Ferris. So my name is Darren Rudnick. I'm an irrigation management specialist here at the University of Nebraska. And I just want to build off of some of the concepts and points that were raised by Joel and Ferris. So as Joel and Ferris kind of brought into light, there's a lot of different reasons why individuals might need to do deficit irrigation. And some of those are actually most, if not all of them, are usually out of a person's control, but it really dictates the options that you have to manage deficit irrigation. And so some of the reasons simply could be declining groundwater levels, reduced stream flows. Some locations have restricted pumping, so water allocations. Sometimes it's simply a capacity issue and you can't pump enough water to meet that evaporated demand. And then oftentimes when we're looking to save a few dollars, we might enroll into load management. And then when we hit these short or maybe even extended drought periods, we might find ourselves where our wells are being turned off, and then we are basically having to manage that or decide whether or not to remove ourselves from those programs. Next slide. So one thing that Joel really hit on in his last slide was the fact that there's a lot of different ways in how we manage deficit irrigation and the impact of that water stress. And so when we think about how crops are going to respond, we have to factor in both the timing as well as the magnitude of that stress. And we also have to be understanding of the fact that different crops can tolerate water stress differently. And also there are hybrids that are maybe more regionally specific so that they can handle the conditions. And so we might see something that's more in our area and a semi-arid condition be more favorable to handle those stresses as compared to something that is maybe more grown in the I states. So when we think of water stress and what it can do to a plant, one thing that we need to kind of think about is how a plant really handles water and how it cools itself. And so the plant does a cooling by actually transpiring, and then it has that evaporative cooling. So when a plant starts to go under stress, it will start to contract or close their stomata. And when they do that, that plant no longer has an ability to cool itself and starts to heat up. And that's what I'm trying to show with some of the data here on this graph, which has the x-axis as cumulative irrigation and the y-axis is canopy temperature. Now, this isn't going to necessarily say how it's going to play out in terms of yield, but it is one thing that we have to be mindful of. And so we have to be thinking about what techniques and practices do we have that we can keep that transpiration going. So we've all seen what a stressed plant looks like, and I have just a few pictures to illustrate. So these are pictures that my PhD students took last week here in North Platte, Nebraska. As Joel mentioned, this year has presented a few challenges relative to the amount of rainfall that we've had. And so here on the right, you basically can see a rain-fed versus full irrigation. And then in the picture, we basically pulled some years where beginning dents or early stages of the dent growth stage. And so now the question is, if you're between A and B, how do you manage that? So another quick picture. So here are some soybeans back in 2018. and very crisp, clean cut. You can see simply if you have water versus if you don't have water. And sometimes these visuals are very telling, but when we're thinking about yield, sometimes we don't have such a black and white contrast. And so we're working with really trying to pick up subtle differences, often that we can't visually detect. And so then we really have to fall back on some of the technology and resources, as Ferris mentioned in his presentation. So here's a few pictures of some of the irrigation trends that we have in North Platte back in 2016. You have on the farthest left-hand side rain-fed all the way to an excessive treatment of 140% of what we deem to be fully irrigated. Go ahead and hit the next slide, Tyler. And so if we look at those pictures and we translate that in terms of how much yield did we get relative to irrigation, we can see this nice diminishing return, so this production function as we go up. So one thing to illustrate how timing can have an impact, we had two other treatments randomized in that experiment where we did a shutoff at R3 and R5 for the soybean. Now, when we think about irrigation, obviously 2.5 inches, most people, even in low capacity wells, they're going to be able to provide 2.5 inches. So if we remove the total amount of irrigation that we have applied, but if we take the same response maybe this year in 2020, we can see that depending on rainfall and irrigation, if we're simply looking at trying to provide everything we can, and if we run out of water, so maybe in an allocated setting, we know soybeans are very favorable to our August conditions when they're filling that grain. And so if we're just applying during that vegetative period, we're missing a critical time period, and it is going to show up in terms of our yield. So when we think about these sensitive time periods, there's obviously differences in crops and a little bit in terms of hybrid, but this is kind of a general view, and Joel already talked about it a little bit, but we know that some of the less sensitive time periods are going to be like right around ripening, so what we're kind of going through right now. So we're getting closer, and when we look at that production function, we could tell that that slope is much higher, but as we get closer and closer to maximum production, we're getting less per input. So we're getting less yield per inch of water applied. And so that's why that ripening period and timing that last irrigation is so important, as Ferris mentioned. Now, what we do know is most crops, they're most sensitive right around that flowering time period. And so for corn, when we're thinking about silking and pollination, we don't want to short. And so whether we're under a low capacity or if we're under an allocated setting, we want to do our best to make sure that we're going to have water at that time period. And so when we're under a low capacity well situation, it might be as simple as making sure we're buffering the soil. And when I say that, I mean, if we know we're not going to be able to meet ET at that period, we want to make sure that we have enough water in that profile. So once we do hit that period, we can carry ourselves through with minimal stress as possible. But we also need to be thoughtful that we can't just kick on the well, let it run constantly, because we want to take advantage of any rainfalls that we might get during that time period. So it is a little bit of a check and balance, but those are a couple strategies. So I think I had this slide in here again to talk about the fact that there is that diminishing response. And so when we get closer to that end of the season, we need to be thinking about when to turn off, because that tends to be the less sensitive period for stress. And it's also at that point where we're hitting that economic optimum. And so we want to make sure we're doing what we can to time that last irrigation. So I wanted to go ahead and provide some general overviews of some of this stuff. And Joel and myself and others, we've done kind of a lit review, and we pulled a lot of data from across the High Plains. And we wanted to look at some of the research findings in terms of how does yield respond to deficit irrigation. And so we did this review, and if interested, please reach out to any of us and we'll be able to share it. But I want to go ahead and just highlight some of the outcomes of that review. So first, we know grain yield is going to increase with irrigation up to an excessive period. But what we do know also is that that is location specific, and it most certainly varies year to year. So we simply can't rely on last year's irrigation versus grain yield response, and we need to be thoughtful of what are the climatic and environmental conditions for the given year. We know residue is very, very important, and I think Joel's data speaks to that. So we also need to be very thoughtful of crop and land management practices. So back to that residue, that tillage, and we want to minimize those unbeneficial water uses. And you can go ahead and hit through them, Tyler, if you'd like. So we also know that grain yield response is affected by that timing and amount of water. So we want to make sure we tackle those critical growth stages. We want to make sure that we're managing each year independent of what's happened in the past. We could use the back in the history to figure out how we want to manage, but we don't want to go into a simple calendar schedule. And when I say that is, we don't want to just simply irrigate once a week because we feel like we need to, or it worked well in the past. We want to be really, what is the evaporative demand? How much water do we have in the profile? Do I need to irrigate at this point in time? We also need to factor in as we go into deficit irrigation, we are increasing the range or the variability in potential yield, and that brings in its own risk, and especially when it comes to your economics. And then lastly, deficit irrigation practices are not universal, and we have to tailor them to the region as well as your own operation. Next slide. So I have, and go ahead and click through this. Just a couple slides just to kind of show some maybe direction. I think Ferris really hit on a couple very important parts when you think about a system. So just because we might be limited in water, it's also very important that we have our systems operating at the most efficient as they possibly can. This graph kind of illustrates that if we want to hit a certain yield, if we have a system, say we're putting on very shallow depths of water, that water is staying in the canopy and it's evaporating and we're not getting into the soil, it's going to take more water to get to that same yield as if we have that system where the sprinklers are allowed to get as much water into the profile and we're basically maximizing application efficiency. Next slide. We also need to be thinking of our rotations. If we're in a deficit environment, it might not be possible to do continuous corn. And so this obviously goes well beyond just your production, and it's also your markets, the economics, and what your system can handle. So, and the last slide, I'm a true believer, technology is very critical. It is something that allows us to identify when and how much to irrigate, especially when we can't visually detect it. As always, if you have any questions, feel free to reach me. I believe my contact information is on the slide.
Well, thank you, Darren, and thank you, Ferris and Joel. And thanks for everyone for listening to the deficit irrigation breakout session. If you have any questions for any of the three panelists, you can send them to us and we will forward them and make sure they get answered. And again, thanks for tuning into the deficit irrigation breakout session.